Question number 7. By sketching a suitable pair of graphs, show that the equation has exactly one root. This means quadratic curve and sad face. 4 minus x square means this curve. This is 4. But we have to sketch from 0 to pi, so only this part, not this part. And sec half x, this means first sketch cos half x. Cos half x. So this is cos half x. Cos half x intersects x-axis at pi. You all know how to sketch cos half x. So this is cos half x and this is sec. Sec is the reciprocal of cos. So this is sec half x. This is the way to sketch sec half x. First sketch the basic function, which is cos half x, and then just reciprocal, sketch sec half x, reflect this cos about this line. But this sec should be parallel to this line, because sec half pi, sec pi by 2 will be infinite. When you will put pi here, you will get infinite. Now I will sketch both the curves on a single diagram. Make sure you label both the axes. This is pi, this is cos half x. You don't need to sketch cos half x, it's just for your conceptual clarity. Now this is sec half x. And this is parallel to this line. You should label this curve. It's sec half x. And this number is 1. This is 4 minus x square. This is 4. And according to this diagram, there is just one intersection point. Hence shown that this equation has just one solution from this interval, 0 to pi. The second part of this question is verify by calculation that this root lies between 1 and 2. So first we need to rearrange this equation. Four minus x square and sec half x. We can write this as 4 minus x square 1 upon cos half x. And when we will bring this here, we'll get 4 minus x square cos half x is equal to 1. So finally we have this equation. 4 minus x square cos half x minus 1. You have to bring this on left hand side. So f of 1 is, make sure your calculator must be in radian mode, 1.6327, positive answer. And f of 2 is negative 1. so negative answer, hence shown. Since f of x changes its sign from positive to negative, hence the root of this equation lies between 1 and 2. Now we have to use this iterative formula to determine the root up to 2 decimal places. Number one, we have to write the formula in terms of cos. So it should be 4 minus 1 upon cos 0.5x n. Now substitute this formula into calculator. Initial value. The initial value is 1 because root lies between 1 and 2. So this is the x1. When we will substitute 1 into this formula, we will get 1.6913. And we have to show the results of each iteration up to 4 decimal places. So this is 4 decimal place number. Now we have to repeat the process till we get a repeated number. You can use answer key of your calculator. So when you will put this in your calculator, you'll get 1.5787. The next iteration, x4. When we will put this number into calculator, we will get 1.5787. For x5, substitute this. Use your answer key of the calculator. 1.6063. So the next number should be 1.600 when we will substitute this into calculator. x7 is 1.6015. x8 is 1.6012. This is 1. x9 is 1.6012 and x10 is 1.6012. This is the repeated number. Hence, the final answer is x 1.60. X is equal to 1.60. We have to give the final answer up to 1 decimal place, 2 decimal places. Question number 8. This question is very simple. We just need to find quotient and remainder. So by using long division, we can easily do this. So 8x cube plus 4x square, 2x plus 7, 4x square plus 1. You all know how to do long division. When you will divide this term by this term, you'll get 2x. 8x cube divided by 4x square is 2x. The result is 2x. When we will multiply this with this divisor, we'll get 8x cube and 2x. Now change the signs, opposite the signs in fact. So we have 4x square plus 7. This 2x and this 2x both are cancelled. Now we have to divide this 4x square by this 4x square. So we'll get 1. When we will multiply this one with this divisor, we'll get 4x square plus 1. Now opposite the signs, the remainder is 6. So the quotient is this 2x plus 1, whereas the remainder is 6. That's it. We had to do till here, quotient and remainder. The next part of the same question, hence find the exact value of this. Number 1, we have to express this fraction in remainder theorem form. 8x cube plus 4x square, 2x plus 7, 4x square plus 1. Well, this is the remainder theorem. Dividend over divisor is equal to quotient plus remainder over divisor. So the quotient was 2x plus 1. The remainder was 6, I guess. And the divisor is 4x square plus 1. So in order to integrate this fraction, first express this fraction into this form with the help of this result. Now we can integrate this fraction easily. I'm writing this result here so that I can easily integrate this. Sine of integral with limit 0 and half and dx. So 0 and half dx plus sine 0 and half dx. This will become 2x plus 1 whole square over 2 times 2, because the differential of this function is 2 and the limits are 0 and half. You can bring this 6 outside the integral to make the integration simple. Well, this is the structure of tan inverse formula. And for tan inverse formula, the coefficient of x square must be 1. For that, you have to take 4 common from these two terms. Well, here we will get 1 upon 4. When we will put half here, we will get 1. 1 plus 1, 2. 2 square is 4. When we will put 0 here, we will get 1. This is 6 upon 4. 0 half. Now, this is very important. X square 1 upon 2 square dx. And this is the tan inverse formula. For tan inverse formula, the coefficient of x must be 1. That is why I took 4 common from these two terms. Well, this is 3 upon 4. This is 3 upon 2. Now use the tan inverse formula very carefully. According to tan inverse formula, we write this thing as 1 upon this thing. Then tan inverse, and then we write fraction of these two. The fraction of these two is x upon half. This is the way to apply tan inverse formula. You must be good at this concept. You can watch my lectures on tan inverse on the channel. 3 upon 4, 3 upon 2. This result will become 2, and this result will become 2x, tan inverse 2x, 0 and half. So we have 3 upon 4. We have to cancel these two. Now apply the limits. Tan inverse, when we will apply half here, we'll get 1. And then tan inverse 0. Tan inverse 1 is pi by 4. Your calculator must be in radian mode. This is 3 pi by 4. Well, we can take 3 upon 4 common, so we have 1 plus 5. This is the final answer, and this is the exact value of the integral. Sorry. The question is find the exact value. This is the exact value. Next question, number 9. Well, we have to solve this differential equation. For that, we need to do separable, variable separable. So we have to bring these two on right hand side with this dx. We have to shift these two on right hand side with this dx, and we have to bring this y on left hand side. So we have dy upon y dx upon x plus 1, 3x plus 1. And then we have to take sign of integrals on both sides. Well, this is the structure of partial fraction. So we have to use partial fraction here to split this fraction. So consider 1 upon x plus 1 and 3x plus 1. So the partial fraction of this fraction will be a upon x plus 1, b upon 3x plus 1. So we have a times 3x plus 1, b times x plus 1. From here we have negative 1, and from here we have x negative 1 upon 3. So by substituting these two values of x one by one into this equation, we can get the values of a and b. So first I'm substituting x minus 1. So when we will put x minus 1, then we'll get a minus half. This is the value of a. Now I'm letting x minus 1 upon 3. Therefore b is 3 upon 2. Now we have to substitute the values of a and b here. So we have 1 upon x plus 1, 3x plus 1. The value of a is minus half, and the value of b is 3 upon 2. Now we can integrate this fraction. So this is equation number 1. dy upon y integral and this entire thing. Use square bracket because this integral is multiplying with both the terms and dx is also multiplying with both the terms. So when we will integrate the left hand side of this integral, we will get ln modulus y. Minus 1 upon 2 is common. So the integral of this 1 upon x plus 1 is ln modulus x plus 1. Always take the coefficients common. 3 upon 2 common, ln modulus 3x plus 1, and the differential of 3x plus 1 is 3, and the constant of integration, which is c. Now we have to find the value of c, and we have this condition x1 and y1. So by substituting x1 and y1 into this equation, we have ln1 minus half ln2 and ln4. ln1 is 0, so we have minus half ln2. We can write ln4 as ln2 square. Now we have minus half ln2. We can bring this 2 here. So 2 upon 2 is 1, so ln2. Now we can take ln2 common from these two. So we have half ln2. Therefore c is minus half ln2. Now substitute the value of c here into this equation number 2. So equation number 2 is this is equation number 2, and the value of c is minus half ln2. Now we have to simplify this. So minus half, we can take half common from this equation. So we have minus ln x plus 1 ln modulus 3x plus 1 and negative ln 2. So by using product and quotient laws, here we have ln 3x plus 1 over x plus 1 times 2. And here we have ln y. We can bring this half here. So we have ln under root 3x plus 1 2x plus 2. Since we have ln on both sides, so we can equate these two, but never cancel these two ln's. Never. So y is equal to 3x plus 1 2x plus 2. We need value of y when x is 3. So y is under root 10 upon 8, which is I think 5 upon 4, which is under root 5 upon 2. So this is the exact answer. The question was find y, exact value of y when x is 3. You must be good at algebra to handle these types of complicated calculations. Question number 10. This is the position vector A and this is position vector B. The line L has equation. Find a vector equation for line A and B through A and B. For that we need to find direction vector of AB, which is Q is equal to AB. This is OB minus OA. OB is 1 minus 2 and 2, whereas OA is 2 1 1. So Q is minus 1 minus 3 and 1. We can use any point for the equation, either this or this. Well, I'm using a point A. So point A is just 1 minute. Two 1 1. Lambda and Q is minus 1 minus 3 and 1. Since question is in ij and k form, so leave your answer in ij and k form. 2i plus j plus k lambda minus I minus 3j and plus k. This is the equation of the line through A and B. Find the acute angle between the directions of AB and L. So this is very simple. We know the formula, angle between two lines. So it should be direction of AB dot direction of L, and their magnitudes should be here. So direction of AB is minus 1, minus 3 and 1, whereas direction of this line L is 1, minus 3 and minus 2. Magnitude of this vector is under root 11 and this is under root 14. The dot product of these two vectors is -1 plus 9 minus 2, and this is 11 times 14 under root. So theta is cos inverse of this entire thing. The answer should be up to 1 decimal place. The last part of this question. Show that the line through A and B does not intersect this line L. This is very simple. This means show that the lines are skewed. So we need to equate r's of both the lines. The r of the line through A and B is 2 minus lambda, 1 minus 3 lambda, and 1 plus lambda. When you will add these two, you will get this thing. And the r of second line is 1 plus mu, 2 minus 3 mu, and minus 3 minus 2 mu. Now solve any two equations. Any two. I'm solving these two. This one and this one. So 2 minus lambda, 1 plus mu, 1 plus lambda, minus 3 minus 2 mu. So by adding these two equations, we have 3 on left hand side and minus 2 minus mu are on right hand sides. So mu is -5. So by substituting this mu into this equation, we have lambda. So lambda is 6. Now we have to substitute these two values, mu and lambda, into this equation because we did not consider this equation for solving. So this equation is 1 minus 3 lambda and 2 minus 3 mu. This equation is not verifying, hence shown that both lines do not intersect, or you can say that lines are skewed. This is the last question of this paper. Find the x coordinate of M, and M is the maximum point. Well, for the x coordinate of M, we need to differentiate this equation. And before differentiating this equation, first simplify this equation to make the calculation simple. This is the double angle formula of cos 2x in terms of sine. So we have sine x minus 2 sine power 3. So when we will differentiate this, we'll get cos x. This is composite function, so 6 sine whole power 2, and the differential of sine is cos. Now equate this to 0. Take cos x common. So 1 minus 6 sine square x. So either cos x is equal to 0 or this entire thing is equal to 0. Cos 0 is at pi by 2, which is not possible in this case because pi by 2 is here and we need this. So according to sketch, this is not possible. Since x is positive, so we will take positive value of this. So sine x is positive under root 1 upon 6. Therefore, x is 0.421. 3 significant figures. and because this answer is in radians. The last part of this question. Using the substitution cos x, find the area of the shaded region. We need this area. Find the area of shaded region enclosed by the curve and the x-axis in the first quadrant. I'm sorry, this is not x, this is 0.421. This 0.421 is here. So area, the formula of area is limit a v y dx. So we need this value, this upper limit. So for limit, for upper limit, we have to equate y0. So sin x cos 2x is equal to 0. So either sin x is equal to 0 or cos 2x is equal to 0. Sin 0 is at 0, at pi and pi 2 pi. All these values are not acceptable because pi by 2 is here. Whereas cos 0 is at pi by 2. So x is pi by 4. So this is the upper limit of the integral. Now this is the formula of area a b y dx. The lower limit is 0, upper limit is pi by 4, y is sin x cos 2x dx. Now we have to integrate this by using this substitution. U is equal to cos x. So u is cos x. Therefore du upon dx is negative sin x. Therefore dx is minus du upon sin x. Now limits. When cos x is 0, this is the formula of u. So cos 0 is 1. When cos x is pi by 4, the value of u is 1 upon root 2. So we have the limits. The lower limit is 1 because when cos is 0, then the value of u is 1. And when cos is pi by 4, then the value of u is 1 upon root 2. This is the integral. Here we have to do the substitution. I'm copying this here. See, when cos is 0, then u is 1. And when cos is pi by 4, then u is 1 upon root 2. Copy this sin x, this cos 2x, and substitute dx by du upon negative sin x. Now cancel these two. See, when the lower limit is greater than the upper limit, then we always switch the limits by writing negative sign outside the integral. So we have to switch the limits here. So 1 upon root 2 should be here and 1 should be here. And here we have cos 2x dx du. This minus and this minus will be cancelled. So we have 1 upon root 2, 1, and we have to use double angle formula of cos here, which is 2 cos square x minus 1. Now we have to substitute this cos by u square. So this is the simplified form after the substitution. Now we have to integrate this function, 2u square minus 1. So when we will integrate 2u square minus 1, we'll get 2u cube over 3 minus u. And limits are 1 upon root 2 and 1. We have to give the exact answer. So when we will apply 1, this limit onto this function, then we'll get 2 upon 3 minus 1. And when we will apply 1 upon root 2, then we'll get 1 upon root 2 cube 1 upon root 2. This will become minus 1 upon 3. One upon root 2 cube means 2 root 2. This 2 and this 2 will be cancelled. So we have 1 upon 3 root 2 minus 1 upon root 2. Well, you can either rationalize this or you can use your calculator. I'm rationalizing this. So this will become this entire thing will become minus 2. I'm taking LCM in fact. 3 root 2 is LCM. So 1 minus 3. You may simplify this with the help of your calculator if you want. So minus 1 upon 3 minus 2 upon 3 root 2. So minus 1 upon 3 plus 2 upon 3 root 2. Now I'm rationalizing this, root 2 upon root 2. So minus 1 upon 3 plus root 2 upon 3. So the final answer is 1 upon 3 root 2 minus 1. I told you, you must be good at algebra to handle these types of very complicated calculations. Because we had to give the exact answer. An important advice for me and for everyone, we must be good to everyone. Good luck to everyone. Allah Hafiz.